Here is a series. We are going to use ratio test to determine if the following series converges or not. So an here is n divided by 5 by n. An plus 1 would be what? N plus 1 divided by 5 to the power n plus 1. For the ratio test, we need to find the limit an plus 1 divided by an in absolute value. That would be limit n approaches to infinity. An is n plus 1 divided by 5n plus 1. Divide that by an, which is n divided by 5n. When we divide two fractions, the denominator fraction flips. Also, you guys notice that all the terms here are positive. So absolute value really doesn't do anything. So we can just remove that. Everything is positive. So this is equal to limit n approaches to infinity. This is 5 to the power n, this is 5 to the power n, which will cancel and only one factor of 5 will be left. So 1 by 5 times n plus 1 by n. How do you find that limit? You divide everywhere by the highest power of n in the denominator. This is 1 by 5. 1 plus 1 by n by 1. We know this thing approaches to 0 as n approaches to infinity. Therefore, our answer is 1 by 5 times 1, which is just 1 by 5. We found the limit. Now we need to check if it is less than 1, more than 1, or equal to 1. This is clearly less than 1. 1 by 5 is less than 1. So what can we say? Using ratio test, the given series converges absolutely. Because of the first. If L is less than 1, the series converges absolutely. Let's do another one. Use ratio test to determine if the following series converges. Here, an is negative 2 power n by n square. So an plus 1 will be negative 2 power n plus 1 divided by n plus 1 whole square. So wherever there is n, you need to change it by n plus 1. We need to find the limit of an plus 1 by an in absolute value. That is limit of n approaches to infinity. An plus 1, negative 2 the power n plus 1 divided by n plus 1 whole square divided by an. What is an? Negative 2 the power n divided by n square. Now we notice the terms which are negative are these negative 2. When you take absolute value, that negative is going to go away. So I'm going to write it one more time. 2 the power n plus 1 divided by n plus 1 whole square. I made it 2. Why? Because the negative is gone because of absolute value. Times the denominator fraction flips and multiplies here. You guys see this 2n plus 1, 2n cancel. Only one factor of 2n is left. So what do we have? Limit n approaches to infinity. 2 n square by n plus 1 whole square. What is the highest power of n in the denominator? N square, because n is in the square. So I divide everywhere by n square. But here n is going inside the square, so you have to divide by n basically. Limit n approaches to infinity. 2 outside. 1 divided by 1 plus 1 by n whole square. We know that as n approaches to infinity, 1 by n approaches to 0. So our limit is 2 times 1 by 1, basically 2. We found the limit. Now we need to check, is it less than 1, more than 1, or equal to 1? This one is more than 1. Clearly, 2 is more than 1. So that concludes what? Using the ratio test, the given series diverges. Here is another example of the ratio test. In this case, an is negative 3 power n divided by 2n plus 1 factorial. An plus 1 would be negative 3 power n plus 1 divided by 2 times n plus 1 factorial. That's basically 2n plus 1, that's 2 times n, 2n plus 2. 2 plus 1 is 3. 2n plus 3 factorial. Okay. We need to find the ratio of an plus 1 divided by an in absolute value, which is limit n approaches to infinity. An plus 1 is negative 3 power n plus 1 divided by 2n plus 3 factorial divided by negative 3 power n 2n plus 1 factorial. Now you guys first notice which one is the negative terms. Only terms which are negative are these. Factorials are not negative. So the absolute value is going to take care of that. We do not have to write negative anymore. So we have 3 the power n plus 1 divided by 2n plus 3 factorial times the denominator fraction will flip. So first thought, this is 3 the power n plus 1. It's one more 3 than 3 the power n. So one factor of 3 will be left. Also, please notice that 2n plus 3 comes after 2n plus 1, right? So how many numbers after? 2 numbers after. So if you expand the factorial of, so we have 1 3 left, and 2n plus 1 factorial divided by 2n plus 3 factorial. So this one I can expand it, 2n plus 3 times 2n plus 2 times 2n plus 1 and so on. So the remaining whole part can be written as 2n plus 1 factorial basically. Okay. Because you have to keep on going until 1. And you see this thing and this thing is exactly same. So this can cancel. So what do we have? Limit n approaches to infinity, 3 divided by 2n plus 3 times 2n plus 2. Now, when n is approaching to infinity, 2n plus 3 is going to approach to infinity. And this is also going to approach to infinity. So whole thing is 3 divided by infinity, which is going to be 0. So we found the limit. What do we do now? We check. Is it less than 1? Is it more than 1? Or is it equal to 1? Clearly, 0 is less than 1. So we have our first case. The given series converges absolutely.